Good morning. Welcome to SAKALAVIDYA YouTube channel. Welcome you all. So for the morning session, so okay, Paraya, Kintali. I could remember. Okay. But initial classes actually I didn't do the basic classes. Definitely I will do the basic class also. Definitely I will do the basic classes. Fine. 1 minute. I will check it now. Levels. Yes. I think now it is okay. Now it is okay. I think so. Right. Oh, Bindu Reddy asking about the concept videos. Thank you, Vital. Thank you. Okay, 19th sem. Yes, Maruti. Correct. So 20th question onwards, I need to discuss. Right, Pavan Sai. Okay. Lakshman Donala, Uppala Sai Teja, Balu. Yes, exactly. Fine. Fine. 19th question has been completed. Now we need to do for 20th question onwards. Whether I may be correct, I do not know. I need to verify. Fine, Vaishnavi. Sarath Sai. All of you had breakfast? I think you have not done. Myself also. Just I had a cup of tea. That's all. So this is the 19th sum completed. Now 20th sum need to be discussed. So after completion of this session, actually I start 2022 batch for JEE mains. In that section, I will complete the basic concepts once again. And JEE mains level questions will be discussed. But that may be done after 15th August. 15th August of this year. Oh, cup of water, good. Water is good to you. Chintu, after long time, Swati, Kirtana Kotla, Avinash, Sudha Ganneri. There is Sumant, Dishwank, Dhruvamsh. Balu is there, Suma is not there. Oh, T-Set, Vittal Kottapelli. Yes. Previously I used to take the classes there. Now, I think long back I presented the classes there. Right, let us start now. Okay, once again, good morning all. Question number 20. Question number 20. if two balls are drawn from a bag containing three white, four black, and five red balls, then the probability that the probability that the drawn balls are of different colors is first option 1 upon 66, second is 3 upon 66, third one is 19 upon 66, fourth one is 47 upon 66. This is the question. Okay, no problem. Manjula, Kartikeya. Okay, Janardhan, Udupi. Two balls are drawn from a bag containing two white, four black, and five red balls. This is first part of the problem. What is the first part of the problem means? The two balls are selected from a bag containing of three white, four black, and five red balls. That means without any restriction, how many number of ways we can select two balls from a bag. That means which is consisting of 3 plus 4, 7 plus 5, 12 balls. So that can be done 12C2. So next second part is this one. Then the probability that the drawn balls of different colors. That means here is a restriction. What is the restriction? The selected balls must be different colors. The selected ball must be different colors means two balls have been selected. If one ball is white, one ball may be black. If one ball is a black, one ball may be red. If one ball is white, one ball may be red ball. These combinations we need to select it. So that we need to do it now. Let us do. Now the solution. First solution is without restriction. This is the first part of the problem. We find out n of s, the total number of outcomes. That means the number of ways of selecting two balls from total balls. Total balls is how many actually here? 3 plus 4 plus 5. 12 balls. Out of 12 balls, 2 balls can be selected at random, that is 12C2. So this can be written 12C2 means 12 times 11 upon 2 times 1. 2 1 ja 2 6 ja 66. N of s is 66. Now let E be the event of getting of different colors. Different colors means here we have the possibilities like this. What are the possibilities now? Here you see the possibilities may be one white ball, one black ball, or one black ball, one red ball, or one red ball, one white ball. These are the possible cases. So this can be done. That means n of e equals to, we can write n of e equals to, out of one, actually one ball need to be selected from three white balls. There are three white balls. That can be done 3c1 times black ball. Four black balls are there. That is 4c1. R means plus mathematically. One black ball 4c1 into one red ball. Red ball is 5 red balls. That is 5c1 plus R one red ball 5c1 times one white ball 3c1. Very simple. 3c1 is 3. 3 into 4 12 plus 4c1 is 4. 5c1 is 5 20. 4 5 are 20. 5c1 5 times 3c1 is 3. 5 times 3 15. This will be 25. 20 plus 15 is 35. 35 plus 12 is 47. So we need to find out now the probability, required probability. P of E equals to, by means of classical definition, we can write n of E upon n of S. This is the basic definition. So number of favorable cases is 47. Total number of cases is 66. That means fourth option is the right option. 47 upon 66 is the right answer. I hope everybody will understand this question. Okay, good morning all. Right. Twenty-first question. Seven balls are drawn simultaneously from a bag containing five white and six green balls. The probability of drawing three white and four green balls is, this is the question. First option is 7 upon 11c7. Second option 5c3 plus 6c4 upon 11c7. Third option 5c2 times 6c2 upon 11c7. Fourth one is 6c3 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 into 5C4 upon 11C7. Right. Right. Option 2. Option 2. 5C3 plus 6C4. 5C3 plus 6C4. Third is 5C2 times 6C2. Right. Let us check it now. See, 7 balls are drawn simultaneously from the bag containing of 5 white, 6 green balls. That means the number of ways of selecting 7 balls from a bag containing total 11 balls. That can be done 11C7 without any restriction. 11C7. That means solution here. N of S is equal to total 5 plus 6 plus C7. That is equal to 11C7. So now here we have 5 white balls and total 6 green balls. How many balls we need to select? 7. What is the condition? 3 white, 4 green are to be selected. 3 white can be selected from 5 white balls. 4 green from out of 6. This can be done 5C3. This can be done 6C4. Here we have AND, not OR sense. AND you need to use. This is the keyword. This is the keyword. That means now let E be the event. Directly I am writing N of E equals to, we can write 5C3 times 6C4. So P of E equals to, formula we know everybody, N of E upon N of S. So that equal to 5C3 times 6C4 upon 11C7. That means fourth option is the right option. Fourth option is the right option. Right. AND means multiplication, OR means addition. AND. Okay, 5C3 means you can write 5C2 also. This third option also correct. Third option also correct. So here actually I need to change, because this 5C3 equal to 5C2, 6C4 equal to 6C2 upon 11C7. That means even third option also correct. Let us modify the third option. So in third option I do, here I will put the plus sign. That's why it is wrong. Fourth option is correct. Fourth option is correct. Now all of you check now. So now this can be written this way. Both are correct. That's why fourth option only the correct option. So sometimes this option may be there in the examination. Instead of plus, here multiplication might be given. Twenty-two. Right. A bag contains 6 white and 4 black balls. 2 balls are drawn. 2 balls are drawn at random. The probability that the probability that they are of the same color, of the same color is first option 1 upon 15, second option is 2 upon 5, third option is 4 upon 15, fourth option is 7 upon 15. So now see option 4. What is the option 4? 6C3. Yes. I need to correct it, this one now. This is 5C3 times 6C4. Okay, now it has been corrected. 6C4 and 5C3. Okay. A bag contains 6 white, 4 black balls. That means there are 10 balls in a bag. 10 balls in a bag. 2 balls are drawn at random. This is the first part of the problem. The number of ways of selecting 2 balls out of 10 balls, that can be done 10C2 ways. That is n of s. Now n of e we need to find out. The probability that they are of the same color. The 2 balls must be same color. 2 balls must be same color means actually either they may be white or they may be black, or sense we are using. That means you can do like this. From 6 white balls, 2 same color white balls can be selected. This is first case. So this can be done 6C2 ways. Now the second case is out of 4 black balls, we can select 2 black, same color. That is also 6C2. 6C2. That means here we use the keyword. The keyword is R. Either one or 2. Here R means we need to use plus symbol. So now let us proceed for the solution. Here solution is n of s is equal to 6 plus 4, 10, 2 selected, 10C2. 10C2 equals to 10 times 9 upon 2 times 1. 2 1 ja, 2 5 ja. This will be 45. 45. Now n of e. Let e be the required event. N of e equals to what? 6C2 plus 6C2. That is 2 times 6C2. So this we can write as 2 into 6 into 5 upon 2 into 1. So 2 gets cancelled. We have 30. Now P of E equals to n of E upon n of S. So n of E equals to 30 upon 45. Simplification is needed. You can do it now. What is the simplification? 15. 45 you got it. Now 45 by 6 into 5. 30. 30y. 15 2 ja. 15 3 ja. Option 4. How did you get option 4? 6 white balls and 4 black balls. Okay. I have forgotten one condition. One condition I have forgotten. Right. They are of the same color. Same color means 6C2. Sorry. I did mistake. Absolutely sorry. गलत हो गया. Here I have written wrong. 1 minute. I will rectify it. This is sorry, not 6C2. This will be 4C2 because 4 only here. So we have here 6C2 plus 4C2. 6C2 is 6 into 5 upon 2 into 1 plus 4C2 is 4 into 3 upon 2 into 1. So 15 plus 6. 15 plus 6 is 21. So 21 upon 45. 3 7 ja, 3 15 ja. So equal to 7 upon 15. 7 upon 15. Okay, correct? Right. Option 4 is the right option. Now the 23rd problem. In a bag there are 5 half rupee, that means 50 NP half rupee coins. 4 25 pies, 25 pies coins and 4 10 paisa coins. Coins, 10 paisa coins. If two coins are drawn from the bag at random, then the probability that the amount drawn to be minimum is first option 9 upon 13, second option 4 upon 13, third is 2 upon 13, fourth one 1 upon 13. This is the question. Right. In a bag there are 5 half rupee coins. That means this is 50 NP coins. 4 25 NP. 4 10 NP coins. 10 paisa coins there are. So now 2 coins are selected at random from the bag. The amount drawn should be minimum amount we need to draw. 2 coins are drawn. That means the value of the two kinds must be minimum. That we need to select it. Because for example, just you discuss in that way, you think yourself, first in a bag there are 5 of rupee coins, 4 25 paisa coins and 4 10 paisa coins. Total coins are there are actually 5 plus 4 9 plus 13 coins. Out of 13, 2 coins are to be selected. So that can be done is equal to 4C2 ways. N of S we know pretty well. But for the second part, as far as second part is concerned, the denomination on the two kinds, if you add them, that amount must be minimum amount. This condition need to be amount. For example, if two half rupee coins have been selected, 50 50 1 rupee that becomes. Suppose if two 25 paisa coins, if you select it, that becomes 25 paisa 50 NP it becomes. Whereas two 10 paisa, if you select it, what do you get now? That is actually two 10 paisa means 20 NP. So this will be minimum. This will be minimum. That means actually here indirectly. So to get the amount drawn to be minimum means it is indirect way that the number of ways of selecting two 10 paisa coins out of 4. That becomes the minimum amount. That can be done 4C2. 4C2 by 10C2 is our answer. So let us do it now. So now 23rd solution. So N of S equals to total number of coins is 5 plus 425 paisa. Next 10 is 4. C2 13 C2. 13 C2 equals to 13 times 12 upon 2 times 1. This is 6. Okay, leave it. After simplification we can do it. 13 6 leave it. That might be 78. Leave it. So next actually see here process. For example, 5 50 NP coins, half rupee coins, 50 NP coins 5. That means if you select 2, 0.5 plus 0.5, this becomes 1 rupee, 1 rupee, 1 rupee, 1 rupee coin. For example, if you select two 25 paisa coin, how many are there? 4, 25 NP. If you select 2, 0.25 plus 0.25, this becomes 50 NP. 50 NP. For example, 4 10 NP. Sorry, this is rupees only 0.5. Okay, 10 NP. That means 10 paisa plus 10 paisa is equal to 20 paisa, 20 NP. This is 0.5 rupees. This will be 20 NP. This will be lesser, minimum. That means we need to target on this 4 10 NP coins. Out of 4, we need to select 2. So that means actually this is the plan. So we get N of E equals to 4C2. Now P of E equals to 4C2 means 4 into 3 upon 2 into 1. This will be 2 times 3, that is equal to 6. So P of E equals to N of E upon N of S. N of E is 2 times 3 upon 13 times 6. 3 1 ja, 3 2 ja, 2 1 ja, 2. So 1 upon 13. This answer. One upon 13. It's very simple. 4C2 upon 13C2 is P of E. So whatever actually we have done, these calculations need to be done in our mind itself only. Okay. at random at random all the letters of the word at random all the letters of the word article are arranged in all possible ways in all possible ways all possible ways the probability that the probability that the probability that the arrangement means permutations, you remember. Arrangement begins with the vowel and ends with consonant is. First option 1/7, second option 2/7, third option is 3/7, fourth option is 4/7. This is the question. Right. At random, all the letters of the word article are arranged in all possible ways. This is the first part of the problem. So first let us discuss the first part of the problem. How many number of ways the letters of the word article are arranged? That is the question. Article means actually 1, 2, 3, 4, 5, 6, 7. They can be arranged in a row in linear permutations. That is the 7 factorial ways. 7 factorial. No repetition are there. Next, let us go for the second part. The probability that arrangement begins with vowel, end with consonant. Here condition, restriction is there. What is the restriction? We need to find out the number of arrangements in which the letters begin with vowel and ends with consonant. That we need to find out. That means first place should fill with vowel, second place, last place should fill with the consonants. After filling vowel and consonants, the remaining places are to be filled. So that is the required number of ways. Required number of ways means favorable cases. After getting the favorable cases, next the total number of cases we know. The favorable cases divided by the total number of cases, we get the required probability. Okay, let us proceed now. Here 24th solution. The word is article, A-R-T-I-C-L-E, article. Now write down number of letters, total number of letters. Number of letters is equal to 1, 2, 3, 4, 5, 6, 7. Now number of vowels write down. Vowels. What are the vowels? A, E, I. Number of vowels is 3. Number of consonants. Number of consonants are, what are the consonants? R, T, C L, that is 4. Okay, first let us write n of s. N of s is equal to the number of ways of arranging 7 letters. 7 letters can be arranged actually here how many places? 7 places without any restriction, without any repetition. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. The 7 places can be filled how many ways? 7p7, that is 7 factorial ways. You leave it, 7 factorial ways. Let E be the event, n of E. N of E means what is the condition here? So now the 7 places 1 2 3 4 5 6 7. This is first place, this is the 7th place. First place fill with the vowels. So that means any vowel here, V here fix constant. So vowel means how many vowels are there actually here? 3 vowels. So this can be filled with out of 3 vowels. So one vowel is fixed here. Here this can be filled 4. This can be filled with 4 vowels. 4 vowels. Okay, that means already one vowel is fixed, one consonant is fixed. That means rest of how many are there actually here now? So this can be filled how many? 3 ways we can fill. Either A or E or 1. So that means one vowel can be selected here, that is 3C1 ways. So one consonant can be selected 4C1 ways. Multiplied by rest of them you need to remove. So 7 minus 2 rest of them is, because already one vowel one consonant is fixed. 7c minus 2 is 5. Now 1 2 3 4 5, this can be filled 5 factorial ways. So that means required number of ways is 3c1 into 4c1 into 5 factorial. So let us write it now. So this equals to n of e equals to, you get 3c1 into 4c1 into 5 factorial, that is 3 times 4 times 5 factorial. We need P of E, probability of E. P of E is equal to n of E upon n of S. So n of E is equal to 3 into 4 into 5 factorial upon 7 factorial. You know factorial is the shifting property. So that can be written 3 into 4 into 5 factorial upon 7 factorial can be written as 7 into 6 into 5 factorial. 5 factorial gets cancelled. 3 1 ja, 3 2 ja. 2 1 ja, 2 2 ja. So that means 2 upon 7 is the right answer. 2 upon 7. 2 upon 7. Please all of you go through it. It may be complicated. You think that it's not a complicated. Here we have the 2 problems we have done. Total 3 problems. 2 problems means first problem is without any restriction. Number of ways of arranging the 7 letters arrangement we need to find out. Second is the condition. It should begin with vowel. It should end with the consonant. So that we have completed. After that we evaluated the probability, required probability. Okay. Right, next. Question number 25. The letters of the word the letters of the word the letters of the word Eamcet Eamcet letters of the word Eamcet are arranged arranged in all possible ways. The probability that the probability that the probability that no two vowels no two vowels come together no two vowels come together in that word is first option 1 upon 5, second one is 2 upon 5, third is 3 upon 4, fourth option is 1 upon 4. First, all of you read the question carefully. First, look at the screen, all of you. Look at the screen. Right. The letters of the word Eamcet are arranged in all possible ways. First, the number of ways of arranging all the letters of the word Eamcet. That is the first question. The second question is the probability that no two vowels come together. First, we need to solve the two questions, n of s and n of e. N of e by n of s is our answer, the probability. So that let us do it now. 25 solution. Eamcet number of letters, that means total number of letters in the word Eamcet. 1, 2, 3, 4, 5, 6. 6 letters. Number of e's repeated are there. Number of e's 1, 2. Rest of them are different. The two are same kind. First, let us write n of s. N of s is equal to the number of ways of arranging the letters of the word Eamcet without repetition. That means 6 factorial upon number of is 2, that is 2 factorial. Okay, leave it now. Simplification we can do later. So now what is the condition we have here? No two vowels come together. That means you write down like this. Let us consider two is that is EE as one unit. Now 6 minus 2 plus this 1 unit 5 can be arranged in 5 factorial in 5 factorial, and also these two can be arranged only one way, into 2 factorial by 2 factorial. So that can be done. That means actually you get like this. Vowels come together. Vowels come together. Sorry. 1 minute. I did mistake. Okay, let us visualize it first. Okay, what is the question now here? Vowels come together. Vowels come together means what are the vowels here? A, E, E. Vowels means actually pack A, E, E. 3 vowels plus now 6 minus 3. 3 plus 1 is equal to 4. We need to arrange 4. This can be arrangement can be like this. 4 factorial, but among themselves vowels can be arranged 3 factorial upon 2 factorial. This is equal to 4 factorial into 3 into 2 factorial. 3 you will be getting. 3 times 4 factorial is the come together. So let us consider now. Let us consider 3 vowels. 3 vowels, that is A, E, E as one unit. Now this can be arranged in 4 factorial into 4 factorial. Here now among themselves they can be arranged 3 factorial by 2 factorial, whose value is equal to 3 times 4 factorial. But what is the condition actually? Vowels should not come together. That is n of e. N of e is equal to number of ways that no two vowels come together. No two vowels come together. That means total minus come together. Total means here actually 6 factorial by 2 factorial, that is equal to 6 into 5 into 4 into 3 factorial. 2 factorial cancel. That is 6 into 5 into 4 into 3 factorial minus 3 into 4 factorial. So this is 6 into now P of E equals to N of E upon N of S. So now simplification you do it, you complete this one. So next class I will discuss regarding this question. Okay, just try your simplification. What is the simplification now? Tell me. I will complete it fast. What is the value of this one? So what is the value of this one? 120 into 6, 3 factorial is 720. This will be now 720 minus 72. 4 factorial into 2. 720 minus 72. 8, 4, 648. 648 upon 720. Okay, simplify this one. Simplify. Okay, thank you. Okay, we shall discuss this question same again. Yes, P of not E. P of not E also we can do. Yes, P of not E also we can do it. Very simple, very good. P of not E also we can do. That we will discuss later. So thank you, bye bye.